screen share. I hope this is visible to you all guys. ये है क्या visible? Just let me know. Fine. Okay, so today's topic is random forest. So we have discussed about decision tree. If you guys are clear with decision tree, in that what we do, we talk about there are one type of node in which we try to put a decision each and every time when we try to do something like based on some feature we give it a value and we'll try to predict the next level until then until unless we find the purity, right? Pure leaf or leaf node. But see, that algorithm name is decision tree. You should watch decision tree before coming to this lecture. The part is in decision tree. There is a word known as tree. And why tree? So this is a tree-like structure where we have nodes and yeah. So in a real world example, real life example, real world, we know that multiple trees, like tree look like something like this. Again, multiple trees when are in together gives a rise to a forest, right? In forest we can find multiple trees. So similarly concept is there कि multiple tree we will implement in a forest. Which type of tree? Decision tree. So that's why its name is random forest. So one thing make clear कि random forest is nothing but your when you use multiple decision tree to solve your problem or multiple decision tree algorithms to solve your problem, right? Another key point is that it is used for both classification as well as for regression and regression. Okay, now before starting this, there is one of the famous thing which you should know, that is called bagging technique. Right. Is it visible and my voice is audible, right guys? Put a thumbs up. Anything. Okay, okay. And then we'll continue now. So bagging technique is one of the technique which we mainly use for random forest. Like random forest uses one technique known as bagging technique. What is bagging technique actually? What does this mean? Can I make it first? First. No, I can't make it first. Okay. So in bagging technique, what we have? We have what data set. We'll change the color of data set, and we use multiple models. Base model, multiple model. You can call it base model also. Right. Sorry, I should put it on this one. Multiple model. Let's say model 1, model 2, model 3, model 4, model 5, 3, model 4. So multiple models. It can be your linear regression, it can be your SVM, it can be your naive Bayes, it can be your anything. So when you use multiple model to solve on a particular data set, means for example, instead of using one algorithm, कि भैया I will use naive Bayes only. See, let's say there is a two person, me and you, not like A and B. Let's say A and B. So A is telling like to solve a problem on this data set, what I will do, let's say some heart related data set we have. So what A will do, A will take, okay, I'll take naive Bayes as my model, like algorithm, and I'll train on it, okay, based on whatever EDA that person have performed, that A person. But what's the case over here with the B person? It think like why I should use only naive Bayes? Why I can't use multiple model to train on the same data set, and I'll get the result. I'll merge all the result with them, and what will be the best result? I'll put it out, the majority result. So what B did, like B worked, for the same data set, he took this data set, that the heart related data set, and used multiple model. SVM also he used naive Bayes also. Let's say two model, right? B work and over here A work. What A did? A just did heart related data set. He performed ADA. Both of them performed ADA. Both of them performed feature engineering. Both of them performed data pre-processing. Everything is same. Just one thing, what makes the difference at the end for both of them was what A did, he directly used naive Bayes. But in the B's work, he used both of the algorithm, SVM and naive Bayes. He trained the data on both and predicting the same thing. Like let's say naive Bayes predicted, he is a heart patient, and SVM also told he is a heart patient. Now he's too much sure about it, and he gave him one result that he is a heart patient. Over here, what is A's work? A only used one algorithm, right? That is naive Bayes. So he got around, okay, he is also a heart patient. But over here, what is the key difference between both of them? You can find that there is one more surety of the SVM. SVM is also predicting, means where only A is using one algorithm, B is using two algorithms, right, for the same problem. So here you can assure more. Assurity I am talking, not accuracy. Assurity, you can give more assurity to this, right? Because instead of saying by one person, it is saying by 2%. Right. That is technique is known as bagging technique. When you use multiple models on the same data set and combine the output of both to get a result. Okay, what is the final result? Then it is called bagging. So what happens if it is a linear classification case? I'll take an example for classification and I'll take an example for regression. So in classification case, like for this one, the above one, it will check for, let's say it can say either a heart patient yes or no. Yes or no. Both of them told that this is a person with a heart patient. He is a heart patient. Yes, means we got from both of them algorithm that. Sorry. Yeah, he got ki both of them are heart patient. Then fine. This is the classification. How it works? There is a one small concept known as majority voting classifier. बोले तो क्या कि what is the major vote? Like over here we got one yes and another yes. 2 yes we got and 0 is no. 2 yes, 0 is no. So the output will be based on this classifier will predict the person is a, like using one algorithm to predict the best one. Yes. Right. Are you guys getting what I'm trying to say? Those who are night owl like me. So yeah, and we'll talk about regression now. In the regression case, what happens? No, if your data set is a continuous data set and you want to predict a particular value, let's say you use some data set over here, use multiple models, M1, BMW M2, BMW M3, right? 3 machine learning models you have. This is known as nothing but base models. You can call it base models. Now, it predicted 0, it predicted 0.2, it predicted minus 0.1, right? So what is the case over here? Now, we will use average, we'll do average, or we'll try to find mean, other word you can call it, if data set is continuous data or the problem is a regression type problem. If problem is regression type problem. Is this concept clear? What is bagging? Using multiple model to predict the same problem, that is known as bagging. Is it clear, guys? Yeah, okay. Aditya, is it clear? Okay, bro. We'll go down and we'll continue with our next part. That is nothing but random forest. So again I am repeating, if you have not went through decision tree, go learn that part, then come to this. Else you can get the concept, but still how decision tree works, that is there in the last class. So you should complete that first. So random forest, in that what happens now, this is your data set. This is your data set. Random forest uses only, I'll put it in red color, uses only decision tree as base model. Right. So whatever the models I am using or gonna use is nothing but decision tree 1, decision tree 2, decision tree 3, decision tree 4. Let's say depending upon how many decision tree are there. That is totally depending upon me. I can choose. Right. DT1, DT2, DT3, DT4, whatever, how many you want, you can put the name. Now the part is how it works. Let's say your data set have m columns and n rows. Alright, m column and n rows. बोले तो क्या? M in this way, m columns and n rows. First row, second row, third row, till dash 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 till n row, and similarly dash 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 till mth column. Right, mth column and nth row, the last. So what happens? No, there is a process known as row and feature, like row sampling and feature sampling. Row sampling and feature sampling. What happens? While giving the data for first decision tree, we don't pass all the data. We don't pass all data. PASS all data. We don't pass all data. What we do row sampling and feature sampling. Sampling bole to we'll select few columns from this first time, second time it can be repeated, like this column again selected, this column again selected, and sent to the first decision tree model. We'll take an example more better. Like first column, it can be any column, it can be the last column also, it can be middle, randomly. It will select random column and it will send to the first decision tree. And for the same column, this rows will be sent. Right? So some of the, let's say, J and K rows and columns will be sent to first decision tree. In second decision tree, this column might get repeated. You can repeat these columns. Like there is a probability, repetition. With repetition, you can repetition. Not always, but few columns can get repeated in another decision tree. For example, if you talk, let's say this is the first column. I'll put column for this one for a better example. Okay, sorry. Let's say we have first row, second row, first column, second column, third column, fourth column, fifth column, sixth column, and seventh column. We call it a feature per column, any same thing, nothing different. But in machine learning term, we call it as features. And rows or samples, you can call it as samples. Not samples, instances. Right. So let's say we have 1, 2, 3, 4 and the last one, 5 rows and 7 features, like 7 features and 5 instances. So what will be the case for the first decision tree? Let's say I am using 3 decision tree 1, decision tree 2 and decision tree 3. So for the first decision tree, what will be the case? It can select the first, third and seventh one, right? First, third and seventh sent to decision tree first. This features. What about the instances? 3 and 2, let's say second and third, right? For the decision tree 2, what can be selected? It can be selected 2, 4 and 7, let's say. So it can be repeated. 2, 4, 7 can be repeated. 7 is repeating, right? And same way 4 and 2, let's say. So 2, 4 is also getting sent to decision tree for the model training. What is sending means over here? To train the model on these features and these instances only. Like we are distributing our data into multiple data sets, small, where you can repeat some of the instances or some of the features, and you train separately multiple decision tree models. Like multiple tree will create forest, right? The basic concept. Similarly, we are just distributing our features and we will cover all of the instances and all of the features, right? We'll not leave any of them unless it is necessary, like feature selection or something if you are putting, unless it will select all the whatever 3 and 5, 1, 3, 5. right? So every column and every row will be covered and will be trained. Each and every decision tree will be expert for some of the particular type of data, right? See, it is seeing only 247 column, 247 feature this column. So this is only expert for these three, right? Similarly, way decision tree 3 is watching only first and fourth. So it is only expert of first and fourth feature. So whenever a new data set or test data comes, this data set will be sent to this also, this also, this also, and every combinedly will give you a result, give a result. And again, if it is classification, we will use majority voting classifier. If it is a regression problem, it will be used average and mean, right? Are you guys getting what I'm trying to say? Yes. Okay, any doubt till here? Any kind of doubt? That is row sampling and feature sampling. So what you can conclude over there from this part, ki the number of rows and the number of features what we are sending for the model has to be always less than the total number of rows and features. So what you can conclude, let's say if your data frame DF, data frame have m number of features and n number of rows, what you can conclude that the feature selected, that is m dash, is always less than m for all decision tree, and n dash is always less than n, not equal to also, less than, right? If m is your number of features, m is features, and n is your instances or rows, right? So this is the main conclusion from this. And again, one key point I'll write over here, replacement is allowed. So row sampling with replacement is allowed. I think so. Feature sampling is not allowed. Feature repetition is not allowed. I think so. I'm not clear. You can check it out. I'll check right now. Let's make it clear. Just a second. Features. No, rows are allowed. You can multiple times you can use this rows, multiple times. But this feature one, no, I am not sure. Let me check, because in my notes it written row sampling with replacement, not feature sampling with replacement. Like feature sampling means distributing in multiple small parts. What that means, sampling. But with repetition means you can select this type of row multiple times. The same candidate. For example, this person can participate in multiple sports. For example, there is a university conducting a sports event. So there might be a rule that one student can participate in only one event, right? So one student, one event. So this is without replacement. This is without replacement, right? With replacement means a student can participate in more than one event. So similarly, one row can participate in more than multiple decision trees. That is with replacement. Row sampling with replacement means this. I'm not sure about this feature sampling. Let me check. Just a second. Yeah, feature sampling with replacement is allowed. So my note was half. Feature sampling with replacement is also allowed. Means you can use multiple features multiple times. Row sampling with replacement is allowed, and this is also allowed. Are you guys getting? Multiple replacement means selecting the same column multiple times. For example, 1, 2, 3, 1, 3, 7 I selected for first decision tree. But I am selecting 1 again and 7 over here again. Over here you can see 4 I am selecting multiple times, 2 times. So you can use same feature for multiple decision tree to train your model, right? This is known as with repetition, sampling with repetition, right? Any doubt, guys? Any kind of doubt? Okay. Now that was the basic concept, and we will be just concluding our session soon with the basics of, this was the main concept of random forest. Now one more concept you can ask for, why to use random forest over decision tree. Like you can ask, okay, we are using decision tree anyhow, so why are we using random forest? So the answer for this is key overfitting. In the last class also we discussed about why decision tree is overfitting too much, because it totally depends upon features, values, how many time it has occurred, and it is like biased towards a particular value, which makes it a overfitting model, right? So what happens in overfitting? There is two cases. First, training accuracy, TRAINING, training accuracy, and one is your test accuracy, right? So when you do training accuracy, you will get low bias, right? And while you do test accuracy, you will get very high variation, very high variance, not variation, variance, which makes the model overfit. Like low bias is good, which make training accuracy high, but test accuracy reduces as the variance increases. So to reduce this problem, that's why overfit occurs, because your test accuracy is low and you are getting high variance. Like your your model is not able to point accurately to this. See, this is your target point. No, it is pointing toward this. So there is a lot of difference, right? So this is to reduce this problem in the test accuracy variance. Like decision tree is too much of overfit due to this one, test accuracy and very high variance. So we use multiple decision tree to reduce the variance. Why? Say if you add more number of decision tree, the variance will be distributed. And the distribution of the sample data into the multiple model will happen. For example, over here, if some of the features are selected for this one, so this is only an expert for 2, this is only expert for 3, this is only expert for 3. Which one? Decision tree model 1, decision tree model 2, and decision tree model 3. If you train a particular model, decision tree, let's say decision tree 4, which is having all the features and all the rows, so it will be having more variance. To distribute this problem, we will distribute into multiple small decision tree, with all of them has to be master of the data what they have seen. So like multiple decision tree reduces the sample, right? Because we are getting a multiple base number. If you add more number of decision tree, variance will be reduced. Variance will be reduced. This is the reason why we use random forest over decision tree, to reduce the overfitting, right? For example, if your data is leaf node, it found a leaf node, again for the next it found one leaf node, and another it found another thing, then again one leaf node. So over here you are finding 3 leaf node consecutively, and if you are having multiple data, let's say 7 or 10 features, so at that time very high chances of decision tree to be overfit. Again, it totally depends upon your data set. Right? So this is one of the important term, why we use random forest over decision tree. Right? Any doubt till here? See, if you add some extra data over here, if you add multiple data more, some extra data, so what it will do, it will divide this data also into multiple data sets. For example, if you add 2 more rows over here, 6 and 7, so 6 and 7 will be distributed among themselves. If you add more features, it will be distributed among themselves. So again, very less chances of model to be get deviated. Meanwhile, if you do slight change in decision tree, the main one, this decision tree 4, and if you add 2 more rows and 2 more features, so your whole decision tree will be hampered. So this is one of the more reason why you use random forest over decision tree, right? So this is a basic thing. Now we will be going for the more basic notes, when to use, why to use, and how to use the basic stuffs. If you have any doubt, you can ask. Only 2 guys are attending class, but it's fine. Any doubt, guys? Should I continue? I can continue, right? Okay. So okay, we'll talk about some use cases, when to use, like where it is getting used. So again, it is highly used in stock market prediction. And disease risk prediction, diseases, diseases, or disease risk prediction. Then image and text classification. One of the famous example, that is predicting customer churn rate, or predicting customer churn, predicting customer churn. Like customer churning means ki is a customer loyal to a particular company or not. For example, if you are having Geo SIM and you are keep on changing to another, next month Airtel, next month VI, next month BSNL, again you come back to Airtel, then you go back to Geo. So if you keep on changing, you are not loyal to one company, and that's why you have, if you want to do analysis, okay, how many like how the person is getting changing as per the company or the requirements. So in this way, random forest is used to find the actually what is the churn rate of a particular type of person, predicting ki that person will be churning in the next month or not. So in that case, we use random forest. So now question is when to use. When to use random forest? Uh, See, in the decision tree, we use it for model interpretability, right? When you want to more understand how model actually understands a particular uh, concept or like particular feature, how it is giving importance to particular feature, at that time we use decision tree. But when to use random forest, uh, I'll write just model interpretability. Means the main part is कि for when accuracy of your model is more important, is much important than your modeling, than your model interpretability. When your accuracy, model accuracy is much important than your model interpretability, at that time you use random forest, right? Again, what just right now Rajat told, a large data set, yes, true. Decision tree get overfit for large data set. Meanwhile, random forest are mainly used for when you are having very high number of feature, when very high number of feature, high number of features, and if you are having much complex relations between them. So if decision tree have much complex relation between features, so it will take time and it might get overfit. But meanwhile, when you have distributed this problem into multiple decision tree, so random forest will come like a leader, okay, and it will guide you, like it will guide the model, okay, distribute the problem like this way, and you can focus on getting more accuracy, right? So again, that overfit I told, so when overfit protection is needed, not overfit protection, protection from overfit actually, protection from overfit is needed, is needed. So this is the basic cases when to use random forest. Just a second. Okay, just I got a call. Then what are the advantages? Advantages of random forest or this machine learning model? First, okay, overfit reduces. क्या? Means machine नहीं, data set. It handles data set much easily as compared to rest of the machine learning models. And yes. Okay guys, continue. Then reduces overfit. It gives more accurate results, more accuracy. Compared to, both are compared to decision tree. Both are compared to decision tree. and one more was there. Handles large data efficiently. Handles large data set efficiently. Actually, you should know this all things, no? Automatically handles missing value. Automatically handles missing value. See, some of the algorithms are there, like random forest is one of them. I forgot one more was there. I think so. I'm forgetting that name. I think so KNN. I'm not sure. I think so KNN. These two algorithms are that no key. If you give some null values to them also, so it will automatically deal with them for the missing values. Right. So these are one of the advantages. You don't have to explicitly handle null values for them. Right. So okay. Now advantages covered. Disadvantages. First disadvantage is again I told you while comparing the when to use. It is less interpretable. It is less interpretable. Then see if multiple decision tree are getting trained now, so it will become little bit slow, like little bit slower. L little bit slower. Then third may require parameter tuning. May require parameter tuning. Right. So for example, parameter tuning, you can ask you what are the concepts in parameter tuning, like number of decision trees, how much trees you want, number of decision trees, or like what is the maximum depth I should go for each maximum depth, how much I should go for each entry. So these are the basic parameter tuning you can give it to a random forest model. So this was all guys, and if you want a basic summary between decision tree and random forest, so decision tree is a single tree, random forests have multiple trees. Meanwhile, decision tree are more likely to be overfit, and it is a very high risk to get overfit. But random forest reduces its main work is to reduce that overfit of decision tree. Another part is accuracy for the decision tree is much in middle only, but for when you run random forest, accuracy boosts. Definitely it will boost. For decision tree, it gives us the interpretability for each and every feature what you have used in your data set and what you have given. But in the random forest, you won't get the interpretability, but that is compensated with the accuracy part. Then for the speed, I'm not writing. If you're thinking here is that part, I'm not writing. I'm just speaking from my notes. Then speed, decision tree is fast to train and fast to predict. Meanwhile, random forest is slower because definitely you are using multiple you're using bagging technique, right? Multiple decision trees you are using, so that is slower. And use cases, the last point, for decision tree the use cases are baseline interpretable models, whereas for random forest it is complex to use and high accuracy needed. When the data is very complex to understand for a decision tree, then you can split into random forest. So this was all guys for the random forest class, and I hope so you understood the concept much well. This is only 33 minutes. Okay, any doubt till here guys? Okay, so we have successfully covered I think so 6 or 7. First is linear regression, naive Bayes, SVMs, decision tree, random forest. 5 machine learning models we covered, and next 2 will be this one, क्या कहते हैं, unsupervised one. So 2 will be unsupervised, then 7 algorithm is more than sufficient. Then we'll go with the project part. Right, so yeah. From tomorrow I'll cover this क्या कहते हैं इसको, unsupervised part, and day after tomorrow we'll start with projects. Like from Friday we'll start from projects, or Thursday. Okay. हाँ हाँ I increased my audio volume from the recording. I use OBS Studio to record, so I got a setting to increase the volume. So right now it will be better. From today it will be better. Yeah, you're welcome. So any doubt Aditya? Any doubt Rajat? Okay, then let's wind up this meeting. Have a good night or whatever we say. Okay, take care. Okay, bro. Good night, Rajat. Good night, Aditya. Yeah, you're welcome, brother.